Students, now we will see the special cases. In earlier sessions we have seen the solid axis is perpendicular to one plane and parallel to another plane, and we have seen the solid axis parallel to both the planes also. Now we will see the solid axis inclined to one plane and parallel to another plane. So this is there in our syllabus, and these are considered as special cases. So this is the syllabus. As we discussed earlier, we are using only rotating object method, and in this case the projections are drawn in two stages, right? First stage, the solid is assumed to be in simple position, right? Simple position is nothing but the axis is perpendicular to one plane and parallel to another plane. So this is how we should start the problem. So to which plane it is perpendicular, on that plane we have to draw the true shape. Final projections may be obtained by one of the two following methods. One is change of position method and change of reference line method. It is also known as auxiliary plane method. So the change of position method or change of object itself, right? So in here we are tilting the object itself. So this method is required for our syllabus, whereas this method is not required for our syllabus. Rotating object method is mentioned in the syllabus. It means that change of position method we need to adopt. So question number 1, a triangular prism of base side 35 mm and axis length 55 mm rests on the HP on one of its base edge. Draw its projections when the solid axis is inclined at 35 degrees to HP and parallel to VP. So here you should underline this 35 degrees to HP. It means that it is given theta, right? So theta angle we know, and now to this plane, initially we need to assume the given axis is, the solid is standing and the given axis is perpendicular to HP. So you have to start from that view. Draw XY reference line. So you are starting from top view, no doubt in that, right? So the true shape is drawn on the top view, whereas the orientation is very important, right? How to orient the true shape, right? So for that it is given, it is resting on HP on one of its base edge. So when it is given as base edge, students, here in the true shape, on right side of the true shape, you make sure that you are getting an edge, right? So when it is resting on edge, you on right side you take edge. Suppose if it is resting on corner, on right side you make sure that you are obtaining a corner, right? So that way you should orient. So here it is resting on HP on one of its base edge. So it is triangular prism, and I have to get a line here, right? On right side of the true shape I should get a line. So this is the line, right? So this is the line I am intending, and this is 35 mm equilateral triangle. So A, P, B, Q, C, R, right? So these are the notations. So P, Q, R are the base notations, bottom base notations. A, B, C are top base notations. Now find its center, right? You know how to find the center, and it is prism, no thick lines involved here, and from here to here it should be thin line, right? And then axis line, right? So from here to here thin line, then axis line, and complete the prism. So the height is given 55 mm, axis length is nothing but height 55 mm. Draw the front view. So this is the simple front view. So here you get P, and here Q within bracket R, and here C within bracket C, B, and here you get A. So all with the dashes. So A dash, P dash, B dash, C dash, Q dash, R dash. So this is simple position. Now you have to tilt this, right? You have to tilt this, and the axis. So this axis line, right? This axis line is 35 degrees to HP. So first draw 35 degrees line, that is axis line. So it can be an infinite line, right? Infinite line. So this is the 35-degree line. So this is 35-degree line. On this line, you make sure that QR is sitting on the XY reference line, and to this line Q dash, R dash and P, this line should be drawn at 90 degrees. So here to draw this, right, one simple way you can follow, this is 35 degrees, and if you draw 90-degree line, this is 90 degree, and this angle can be 180 minus 90 minus 35. So this angle is 55 degrees, right? So you can take 55 degrees and you can start the problem, right? And then it is easy, you will be having drafter, then you can draw the axis line. So that way you can proceed, because it will be very simple, right, if you use this trigonometric concept, right? Very simple. And you can draw the baseline. So this baseline QR, right? QR is somewhere here, right? And you should mark, right, this point, this distance should be maintained, right, here to here. So so this is the line I am reproducing, and the entire view I am going to reproduce here at 35 degrees, right? The entire view I have reproduced here, right? The same dimensions, whatever dimensions I have, the same dimensions I need to adopt here. So now all three steps are over. The fourth step is final uh, projection, right? Final projection. So this is A dash. I am using suffix 1, right, for second step. So draw the lines, and from these are projectors. From front view and top view, draw projectors. The corresponding intersection points you need to obtain. So this becomes P1, right? And this becomes this is Q. So you have Q here, this is Q1, and here you have P1, sorry, R1, and here this is A1, and here this is B1, and you have C1, right? C1. So now the rule, right, first rule I will tell you, you adapt to all problems. All outermost points should be connected with thick lines. So without any hesitation, connect all the outermost points with thick lines. Now A is here, A is connected to B, and A is connected to C. So A is visible, AB is visible, AC is also visible, right? So PA is also visible. So P to A thick line, and A to C thick line, and A to B thick line. Now this is QR. QR is connected to, right, B, that is B1, right? So Q1 is connected to B1, right? So already Q1 is connected to B1, R1 is connected to C1, already here it is connected, right? And it is connected to the Q1 R1 is connected to P also, right? So P1 is already connected here with R1, and Q1 is also already connected. Only line that should be done here is R1 Q1, right? So that is nothing but R1 RQ, right? This line we need to connect, and that should be the invisible point, right? Invisible edge. So here the points nearer to XY reference line, they can be considered as the invisible edges in its corresponding projection. So here this is the corresponding projection. So here I should get a dotted line. So this is the final projection. So this is how you should proceed to solve this kind of problems. This is the first problem. We will see one more problem. A square prism. So earlier we have seen a triangular prism of base height 35 mm and axis length 60 mm rests on one of its base edges on the HP. So it is also resting on base edge. So here on right side, the orientation with this point you have to fix the orientation. With its axis inclined at 30 degrees to HP and parallel to VP, draw its top and front views, right? So you have to draw the square, make sure that square is one edge is on right hand side, and this is the square 35 mm, right? And draw its simple front view. So this is the simple front view. So from here to here, thin line, then axis line, and I am notating ABCD for top base and PQRS for bottom base. And now draw the simple front view with given height 60 mm, right? 60 mm. So this is the first step, simple initial position. Now the axis with its axis inclined at 30 degrees to HP and parallel to VP. Now you can follow the same trigonometry rule that I said, right? Trigonometry concept. So if you adopt that, it will be very easy. Otherwise you can follow you can follow this step also, right? You can draw the axis line. So you can draw the axis line, and then you have to reproduce, right? You have to reproduce this view here, right? So anyway you can follow, no problem. And this is RS, make sure that RS is sitting here, right? And PQ is here and RS is here, and draw the front view. So this is the simple front view, and I am using suffix 1, right, for second step. So this is the tilted view, right? Tilted view. For this corresponding top view, top view projection we need to complete. So similarly here, draw the projections from each and every point, and here also draw the projections from each and every point, projectors. And now we have to mark the points. So this is P, and this is P1, and this is Q1, this is R1, sorry, this is S1, and this is R1, and here this is B1, uh, A1, right? A1, and this is B1, and here this is C1, D1, and here this is C1, right? So only 8 points I am getting here. So all outermost points you connect with thick lines without any hesitation, and A1, B1 is visible, draw a thick line, and S1, R1 is not visible, draw dotted line. So this is your final top view, right? So this is another problem. And third problem, it is a rectangular prism, 50 by 25, base and length, axis length is nothing but here it is height 70 mm, rests on one of its longer edges. So longer edge is 50 mm, right? So make sure that 50 mm is on right side, right, of the base, and the axis is inclined at 30 degrees to HP and parallel to VP. Draw its projections, right? Draw its projections. And this is the front view, right? Sorry, top view, simple top view. So now find the axis, right? And this is the axis, and give notations ABCD for top base, PQRS for bottom base, and you can find out the center by drawing the diagonals. And from here to here thin line, then axis line. Now with 70 mm height, this is 70 mm, right? Complete the simple front view. So this is simple front view, give notations, right? Give notations. So in the next step you have to tilt, the axis should be tilted 30 degrees to HP and parallel to VP. So 30 degrees to HP, and reproduce this view here with respect to this 30-degree line. So use that trigonometry concept that I taught you earlier, right? That will be simple, right? So this is the simple front view. I am putting suffix here. So this the same notations I am using with suffix 1. So draw the projectors from each and every point. So obviously there are 4 points, like earlier earlier case, totally 8 points you get here. So this is P1, and this is Q1, this is S1, and this is R1, and this is B1, right? A1, and this is your B1, right? And this is your D1, and this is your C1, right? So now connect all outermost points with thick lines, right? And now RS is invisible, and AB is visible. So this is the final top view for this given rectangular prism. So fourth one, so this is a pentagonal prism of base height 25 mm and axis length 55 mm rests on the HP on one of its base edges. Draw its projections when the solid axis is inclined at 45 degrees to HP and parallel to VP. Right, draw the projections of the prism. So here it is resting on base edge. So on right side, make sure that you are getting an edge, right? So this is the edge I am talking about, and this is the true shape, right? So draw the true shape properly. It is very important, right? So ABCD, that is my top base, PQRST are my bottom base points. So draw this simple front view, right? Draw this simple front view, give the notations in front view also. Now the solid axis is 45 degrees to HP, right? Solid axis is 45 degrees to HP. So this is the solid axis, right? With respect to this, right, 45 degrees, I am reproducing this view here, right? Same dimensions I am using here to reproduce, right? So with suffix 1. So you can use trigonometry concept and you can draw this line, and then 90-degree lines you can easily draw, right? And then using drafter you can complete the axis line later. So that way you can proceed. So from each and every point, right, I am drawing the projectors. So this is my P1, right? This is my P1 and this is my T, right? This is Q, right? This is Q, and so this is R, right? This is R, and this is S, and this is T, right? One side I have completed, and another side, so this is A, right? And this is B, and this is C, this is D, and final point here E, right? So E1. So here also same rule you apply. Draw thick lines to connect all the outermost points, right? Draw thick lines to connect all outermost points. Now this base is visible, A to B is visible, right? A to B is also visible, and A to E is also visible, right? A to E is also visible. Now A to P is visible, and these are the visible points, and RS are invisible points. So R is connected to Q, right? R is connected to Q, and S is connected to T, right? S is connected to T, and this should be drawn dotted lines, right? So S is connected to R also, so that should be drawn dotted lines. From S to C, right? S to D, right? S to D is also a dotted line, and R to C is also a dotted line. So this is how you should draw the final projections. So this is the final top view, right? So these are invisible points. So next problem. Next problem, that is hexagonal prism. It is a hexagonal prism of base height 30 mm and axis length 40 mm is resting on HP on one of its base edges. So it is also similar to earlier problem. The base containing the resting edge is inclined at 60 degrees to HP. So here the 60 degrees is given. So base itself is making 60 degrees to HP. So that is the slight change from earlier problem to this problem. And the solid axis is parallel to VP. Now it is hexagonal prism resting on base edge. So on right hand side you draw the simple position. Make sure that you are getting an edge here, and give notations A B C D 1 2 3 4 5 6 I have used here. So anyway you can use, no problem. So this is dotted line. So this is the axis line, right? So the height is only 40 mm, so it is little more or less equal to side. So this is 40 mm, and give notations A1 A1, A1 here, 3 6 here, sorry, 2 1 here, BA here, right, CE CF here, 3 6 here, right. So give all the notations. So first complete the simple front view on top view. Now you have to tilt, right, you have to tilt. So you have to tilt now 60 degrees, 60 degrees to HP. Now the base containing the resting edge. So what is the resting edge here? This is the resting edge 4 5. It is the resting edge. The base, the entire base is making 60 degrees to HP. So this is 60 degrees, this is 60 degrees. Now with respect to this, right, you mark the center point. It is obviously center point, right. You mark 3 6, right, 3 6. Now draw the axis line, right. Now complete the rectangle here, complete the rectangle here. So same dimensions we have to use here. And now draw the projectors from each and every point and mark the points, right, mark the points. So this is your one, right, point number one. And this is point number two, point number three, point number four, point number five, point number six here, right, point number six. Similarly this is your B, sorry, A, and this is B, and this is C, and this is D1, and this is E1, right, E1, and here it is F1, right, this is F1. Now connect all the outermost points with thick lines, right, and this is visible. And F2, F2A, right, F2A is visible, F2A is visible. And F2 A to B, right, A to B, A to B is also visible. And B to C, right, B2C is also visible. So B2C is also visible. Now here the invisible edge, right. So this is B2A is visible, A21 is also visible, right, A21 is visible. And B22 is also visible. And now you have 4 and 5 here, right, this is 4 and 5. And these 2 points are invisible points. What are all the edges connecting to these 2 points? They are all invisible edges. So it is 3 is connected to 4, 3 is connected to 4, 4 is connected to 5 dotted line, and 5 is connected to 6 dotted line, and 5 is connected to E also, right, 5 is connected to E dotted line, and 4 is connected to D dotted line. So this is the final projection. This is the final projection in top view, right, final projection in top view. And next problem, a square pyramid. It is a square pyramid of base at 30 mm and axis length 50 mm rests on HP on its base edge. So this is the base edge you have to draw here. Draw its projections when the solid axis is inclined at 40 degrees to HP and parallel to VP, right, A B C D. And from here to here it should be dotted line, right. And draw the simple front view, simple front view. So here this is O, A D is invisible, C is invisible, and solid axis is inclined at 40 degrees to HP. So you have to draw the solid axis. With respect to that axis, you have to reproduce this view, you have to reproduce this view, right. So after reproducing the points, you can obtain very easily, right. So this is A, this is A, and this is B, and this is O, and this is C, right, C, and this is D, right. So totally 5 points. And here also, as usual, connect all outermost points with thick lines, all outermost points with thick lines. And D is connected to O, that is visible. A is connected to O, that is also visible, right. And C is connected to O, that is invisible, but it is the out, it is actually visible, right. So it is visible. And even though it is invisible, since it is the outermost line, that should be connected with thick line only, right. When it is outermost line, it means that it will be a visible edge, right, a visible edge. Now B to C. B to C is not visible, so B to C should be drawn with the dotted line, right? So this is how you should draw the pyramid. Problem number 7, a pentagonal pyramid, right? It is a pentagonal pyramid, and here also base edge 30 mm. It is also resting on edge, right? It is resting on edge. So it is pyramid, so you should draw the thick lines, right? It is a pyramid, slant edges should be represented with thick lines, A, B, C, D, E notations, and this is my front view, right? This is the front view, and now 30 degrees to HP and parallel to VP, axis is making 30 degrees. So with respect to this axis, I have to reproduce this view here, right? I am reproducing the view here, and the corresponding top view is very simple, and you can mark the points, right? So this is A, and this will be B, and this is C, and this is D, and this is E, and this is O, right? O1. So connect all the outermost points with thick lines. Now CD is within, right? It is going inside, so they are invisible edges, right? Whatever is connected to CD, they are invisible, and D is connected to E. It should be a line, right? It should be a invisible edge, right? And D is connected to C, that should be invisible edge. C is connected to B, that is also invisible, and D is connected to O, invisible, right? C is connected to O, invisible, right? A is connected to O, visible, right? So this is your O here, right? This is O1 here, right? O1. So this is the problem, pyramid problem, and all of you should be clear, right, how to identify these invisible edges. So problem number 8, it is a pentagonal pyramid of base height 25 mm and axis length 60 mm, rests on the base side on HP such that the highest base corner is 20 mm above HP. So highest base corner is 20 mm above HP. So what does it mean? The axis will be inclined to HP in such a way that the base is drawn, right? The highest point should reach the 20 mm, right? So its axis is parallel to VP. Draw the top and front views. So it is also resting on base side. So there is no doubt you should draw a edge here. So this is the pentagon, and it is pyramid, so you should connect the center with thick lines. So this is 25 mm side, A, B, C, D, E, right? A, B, C, D, E, and draw the axis line, and draw the simple front view, right? Simple front view. Now to draw the axis inclination, it is very simple. Draw a thin line at 20 mm, right? At 20 mm, right? Draw the thin line at 20 mm. So here you measure this distance, right? You measure this distance and mark CD somewhere here, right? Mark CD somewhere here, mark CD, right? And measure this distance C dash D dash to A dash. Measure this distance and cut an arc on this 20 mm line, right? So now you will get this edge. Now this is the base. The base is a line here, right? After cutting an arc, you will get this line. So now it is very simple. Now you can draw the axis line 90 degrees to this line, right? And A dash, A1 dash, and the remaining points you can mark very easily. So this is how you should draw. There is no angle given. Instead, the A, right, A position is given, right? So to draw that A position, draw a 20 mm line above XY reference line. You mark somewhere, anywhere, right? You mark a point. From there, with this distance, measure this distance and cut an arc, right? So now complete the line. So that becomes your base. That is the base. From that base, you reproduce this view. So this view is reproduced here, right? Now the remaining exercise will be as usual. This is point A, and this is point B, this is point B, and this is point C, and this is point D, and this is point E, right? This is the O, and all outermost points should be connected with thick lines, right? You connect all the outermost points with thick lines, right? Now CD is invisible, so C to D should be drawn with dotted line, B to O should be drawn with thick line, and A to O should be drawn with thick line, and D1C1 should be drawn with dotted line, and A2O also should be drawn with thick line, right? A2O also should be drawn with a thick line. So this is the final projection. This is the final projection. So only difference is there is no angle given. Instead the base is at this height, right? The highest corner is at highest base corner is 20 mm above HP, right? So with that clue you have to proceed in this problem. And ninth problem, a hexagonal pyramid of base height 25 mm and axis length 55 mm rests on the HP on one of its base edge. The solid axis is inclined at 40 degrees to HP and parallel to VP, right? The solid axis is 40 degrees to HP directly given, so there is no problem. You can easily complete this problem like our usual practice. The orientation, it is resting on base edge, so this is the base edge. This is the base edge. Give the notations, and complete the simple front view. And now axis is 40 degrees to HP directly given. You can use the trigonometry concept and you can complete this problem, right? So now these are the projectors from each and every point, right? So draw the projectors from each and every point, and you mark all the points, right? You mark all the points. So this is my A1, this is B1, this is C1, and this is D1, and this is E1, and this is F1, and this will be obviously our O1. So connect now all outermost points with thick lines, right? So CD is invisible edge. What are all the lines they are connecting to the C and D? They should be dotted lines. So now the C is connected to B, right? C is connected to B dotted line, C is connected to D dotted line, D is connected to E dotted line, and D is connected to O dotted line, C is connected to O dotted line, and F is connected to O thick line, A is connected to O thick line. So here draw the thick line. F is connected to O thick line, A is connected to O thick line. So remaining dotted lines, right? These are all dotted lines, and D should be connected with the dotted line, C should be connected with dotted line. So you have to do it very carefully, these lines. And the 10th problem, draw the projections of a square pyramid of base height 25 mm and altitude 50 mm. When it rests on the ground on one of its base edges, it is also resting on base edge. The orientation is clear. It's just perpendicular to VP, right? Perpendicular to VP, and the triangular face containing the resting edge. So that is the lateral face. That is the lateral face containing the resting edge. So obviously the lateral faces of pyramid are triangles. So that triangular face is 90 degrees to perpendicular to VP and HP, right? It is perpendicular to both VP and HP, right? So it is standing in such a way that the triangular face is 90 degrees to both VP and HP. So that is only the clue to proceed in second step, and there is no axis inclination given, and this is very simple problem, right? This is no angle is given, and here this is OBC, right? OBC. So now this is the triangular face. Now you have to draw the final front view and top view, right, in such a way that OBC is perpendicular to both HP and VP. So this is the face talking about, right? So now this face is at 90 degrees perpendicular to both HP and VP, right? Now draw simple front view on top view. In second step it is very simple, right? Very simple, right? Now this is BCO, right? This is BCO. It is now 90 degrees to HP, right? 90 degrees to HP here. So draw this line, right? Draw this line, right? It is 90 degrees. Now this is BC, it is O dash, right? O1 dash, and this is B1 dash and C1 dash, right? So now once you draw this, now this final this is the simple position you can draw here, you can reproduce here. It is very simple. From B dash C dash, from this point to this point you measure distance, right? From here you cut an arc, and from here to here you measure the distance, and from O dash you cut another arc. The intersection point you mark as A dash, A1 dash and D1 dash, and you complete the simple front view, right? Simple front view. So that is simple way you can complete. Now you can draw the axis. So now the midpoint you can connect, and you can draw the axis. So no axis inclination is given here, but the only clue we have here to proceed is OBE, right? OBC should be 90 degrees to both HP and VP, right? So from each point you draw projectors. From front view also you project the projectors. Now this is A dash, and this is B dash, and this is O dash, and this is C dash, and this is D dash, right? D1, right? These are all with suffix 1, and these are the points, right? These are the points. Now connect all outermost points with thick lines without any hesitation. And now A to O should be connected with thick line, and D to O should be connected with thick line, right? And C to O, it is already connected with thick line, so no need to worry about it. And B to O is already connected to O. So now all points are connected to O base points, right? So this is my final front top view, so final projection. When the face, one of the triangular face is perpendicular to both VP and HP. So this is how you should draw this problem, 10th problem. 11th problem, a pentagonal pyramid of base side 30 mm and altitude is nothing but the height. Altitude is nothing but a height of the pyramid 75 mm rests on the HP on one of its base edges such that the triangular face containing the resting edge is perpendicular to both HP and VP, right? The triangular face containing the resting edge is perpendicular to both HP and VP. So here also, right, same as earlier problem, right? Only difference is it is pentagonal pyramid, right? It is the triangular face containing the resting edge is perpendicular to both HP and VP. On right side you draw the edge, right? Draw the edge and draw the pentagonal pyramid, right? It is pentagonal pyramid. It should be drawn with thick lines, and you have A B C D E O, right? So now draw the axis line, and now this is 75 mm height, and this is the simple front view, right? Now this is the C dash, D dash and O dash, and this line you measure this distance and draw at 90 degrees, right? Draw at 90 degrees to HP, right? Now from here, from this point to A dash, you measure this distance, cut an arc, and from O to A dash, you measure this distance and cut another arc, right? You will get this point. This point. Now complete the triangle, right? Complete the triangle and measure this point and draw the axis, and measure from here to here distance and mark B1 dash and E1 dash. Now all the points I have reproduced here in such a way that my OCD, right? OCD is 90 degrees to HP, 90 degrees to HP. So here draw the projectors as usual, and draw the projectors here. So this is A1, and this is the B1, and this is C1, and this is O1, and this is E1, right? This is O1. Now this is OCD is perpendicular to VP here from this view, and OCD is perpendicular to HP from this view. So given condition is satisfied, right? Connect all the outermost points should be with the thick line. B2O thick line, E2O thick line, A2O thick line, right? A2O also should be connected with thick line, right? So D2O is already connected, C2O is already connected, so no need to worry about it, right? So this is the 11th problem. A hexagonal pyramid. Earlier we have seen pentagonal pyramid. It is hexagonal pyramid. Our base at 30 mm and altitude. Height is 75 mm. Altitude means height only. On one of its base edges such that the triangular face containing the resting edge is perpendicular to both HP and VP. So it is also same condition, only difference is it is hexagonal pyramid, and now this is the pyramid. You should connect the O with thick line, right? Thick line, and draw the simple front view on top view. In same way, C dash, D dash, O dash, this should be drawn a thick line. Now reproduce this view here as I said earlier, right? Cut an arc with this distance, and with this distance cut another arc. The intersecting point is your A1 dash and F1 dash, right? And draw the thick lines, draw the thick lines. So these are the projectors from each and every point in simple top view, and draw this projectors from front view also, right? From O dash it will lie on the same line, right? So now mark the points. So this is A1, this is B1, this is C1, right? This is D1, E1, and F1. This is O1, right? This is O1. Connect all outermost points with thick lines, right? All base points should be connected to O with the appropriate lines, right? So this is the thick line E2O, and B2O also thick line, F2O, A2O thick line, F2O thick line. Now you see OCD, right, is the triangular face which is perpendicular to VP now, and OCD is the triangular face which is perpendicular to HP now, right? So given condition is satisfied. So this is how we should proceed in these type of problems. In next session we will see more problems, right?